Hey guys, it's Sukrit from STEM Coder, and today we're going to be using the three elementary row operations we learned last video to transform a matrix into echelon form. Now you may have wondered, well, what's the point of all these row operations? What are we going to use them for? Well, converting a matrix to echelon form is one of them, and in future videos we're definitely going to be using this idea of transforming matrix to echelon form to solve a lot of practical problems. So without further ado, let's get started. Now I'll put up a random matrix over here. Let it be 6, 2, 3, 0, 6, 1, 0, 12, 8. Well, we got a matrix over here, and we want to transform it to echelon form using row operations. This one is simple. Our matrix is almost in echelon form, because recall, for a matrix to be in echelon form, we need the leading entries to be strictly to the right of leading entries above it, and we want all zero rows to be below all non-zero rows. There's a certain kind of process we follow when we're reducing a matrix to echelon form. I'm showing you a 3 by 3 matrix in this case, but this applies to matrices of any dimension. We like to kind of work in a pyramid fashion. We want to first reduce this element to 0. So using row operations, somehow make this element 0. Next, using row operations, somehow make this element 0. And finally, after that's done, using row operations, make this element 0. So first we try making this a 0, then we make this a 0, then we make this a 0. If it's a 4 by 4 matrix, so if it's a 4 by 4 matrix, then it's basically this element, then this element, then this one, this one, this one. So we first do like 1, 2, 3, 4, 5, 6, like that, and so on and so forth. But I'm just using 3 by 3 matrices as an example. This is called the pyramid method. So thankfully, these two elements are already 0, so we only need to make this a 0. How do you think we can do it? Well, why not add -2 times the second row to our third row, because second row is 6, 1, our third row is 12, 8. If we multiply our second row by -2, we'll get -12, -2, and we add that to the third row, well then -12 cancels to 12 and you get 0. So let's try that out. We want row 3. We want to add -2 times the second row. We want to add -2 times the second row to the third row. And so what do we get? Our third row is 0, 12, 8. -2 times our second row is 0, -12, -2. Add them up, we get 0, 0, 6. And so after doing our row operation, we get 6, 2, 3, 0, 6, 1. First and second row remain the same. We haven't performed the row operation on these two rows. The third row, we've added 2 times the second row. 0, 0, 6. This matrix is in echelon form. Matches all our conditions. So let's move on to some other matrices. This matrix over here, relatively simple. We want to just work in our usual order. Make this a 0, make this a 0, then make this a 0. Go ahead and pause the video and try to make this element circled in green. This first element, try to make that a 0. We can achieve that. We can make that a 0 by simply adding -4 times the first row. So why not do row 2 goes to row 2 plus -4 row 1. And basically, if we do -4 row 1, we get -4, 0, 0. Add that to the second row, 4, 1, 0. So 4, 1, 0 plus -4, 0, 0. We get 0, 1, 0. Now, can you try to make this element a 0? This element, this 3, can you try making that a 0? Once again, fundamental row operation, add -3 times the first row. So row 3 becomes row 3 plus -3 row 1. And so first and second rows remain unchanged, but we add -3 times the first row to the third row. So now the third row becomes 0, 2, 1. You can see why I haven't done the math precise. I haven't written out all the steps, but you can see why it becomes -3, 0, 0 when I multiply the first row by -3, then I add it to your third row. So basically this 3 gets cancelled out. Finally, we want to make this 2 into a 0. That's our final element. How do we do that? Well, why not add -2 times the second row? So row 3 goes to row 3 plus -2 times the second row, -2 times row 2. So second and first rows remain the same, and if we add -2 times the second row to the third row, we get 0, 0, 1 over here. And this matrix, and it happens to be the identity matrix, it's just a cool coincidence, we'll talk about this later, but if it's identity matrix, it's definitely in echelon form. It satisfies all the conditions. So we have successfully reduced this matrix to echelon form by making this element, and this element, and this element into a 0. It's called the pyramid method. Let's move on to this matrix over here. This matrix, these two elements are already 0, so we only want to make this element to 0 now. Go ahead and pause the video and try doing it yourself. Over here, we want to make this 8 into a 0, so how do we do that? Well, why not add -2 times the second row, because -2 times 4 is -8, -8 plus 8 is 0. So 1, 2, -3, 0, 4, 5. Our first two rows remain the same. Basically, our row 3 goes to row 3 plus -2 row 2. And when you do that, we end up getting, well, this is our third row, 0, 8, 1. -2 times our second row is 0, -8, -10. Add it up, we get 0, 0, -9. And this matrix, look at our leading elements. This matrix is in echelon form. How about this one over here? Now, we first want to reduce this one to, we first want to reduce this element to 0, right? But pay close attention. These two rows are multiples of each other. So if we multiply the second row by -2, we get the third row. And always, if you find two rows which are multiples of each other, eliminate one of the rows. So it takes precedence, okay, over in our pyramid method. So our second step in our pyramid method is to zero out the pyramid. But our first step is eliminate common multiple rows. So I'm going to put this over here. So zeroing out the pyramid, that's what you did over here. Make this is 0, this is 0, this is 0. But look, these two rows, if you multiply the second row by -2, we get the third row. So right off the bat, get rid of it. Let's do that over here. If we add 2 times our second row to our third row becomes all zeros. Because our third row is -2, -4, -8. 2 times our second row is 2, 4, 8. We add these up, we get 0, 0, 0. And the second row, first row. And now go ahead and do the pyramid method. First, we want to reduce this element to 0, right? So why not just add the first row to the second row? That should work. So row 2 becomes row 2 plus row 1. We're simply adding the first row to the second row. And when you do that, we end up getting 0, 3, 4, 0, 0, 0. This matrix is in echelon form. I have circled the leading entries. The leading entries being to the right of the leading entries above it. That condition holds. And our 0 row is below all our non-zero rows. Now, I have this matrix over here. Why don't you pause the video and try reducing this matrix over here to echelon form using the trick we learned. Eliminating common multiple rows and then zeroing out the pyramid. Okay, let's work this out. Let me do this over here. First step is, why don't you try making this 8 into a 0, because that's what you want to do for a pyramid. There are no rows which are multiples of each other. So I'll just tell you, when you do that, row 2 becomes row 2 plus -4 row 1. Well, row 1 remains the same, 2, 1, 1. Row 2 we want to add to 8, 4, 0, which is our second row. We want to add -4 to, -8, -4, -4. So when you do that, we end up getting 0, 0, -4. So 0, 0, -4. And our third row remains the same, -4, 4, 4. Okay, that's good. Now, why don't we try reducing this element to a 0, this -4. I can just add 2 times the first row. So row 3 becomes row 3 plus 2 row 1, because -4, 2 times 2 is 4, and those two cancel out. So let's do that. 2, 1, 1, 0, 0, -4. And what's this? Let's add to -4, 4, 4. Let's add 2 times the first row. So that's 4, 2, 2. We get 0, 6, 6. Now, look at this, okay? We've done 2 sum row operations, and this matrix is really close to being in echelon form. You can try reducing this 6 to a 0, but I'll just tell you right off the bat, it's going to be kind of difficult doing that. But we have 3 row operations, sum, scale, and swap. Look at this one. If we swap the second and third rows right off the bat, swap the second and third rows. So let me do that. So I want to swap. So row 2, row 3, I swap them. Now if we swap row 2 and row 3, we get this matrix, which is in echelon form. So I'm going to add this third thing. So if at any moment, if you can swap to finish, do it. So what this means is that first you want to eliminate any common multiple rows, and then you want to zero out the pyramid. So in this case, we eliminated the third row because it's a multiple of the second row. Then we did the usual zeroing of the pyramid. But if at any stage in this process of reducing to echelon form, and at any stage you find that by simply doing like one swap, you can complete the whole reduction process. So just doing a swap, you can finish the whole thing. Go ahead and make that swap, because sometimes using this pyramid method may not always be the most efficient way to do it. 99% of the time it will, but sometimes you can end up getting your final answer by just doing a quick swap. So just remember, eliminate any common multiple rows first, then zero out the pyramid in this order, 1, 2, 3. And if you can swap to finish the transformation, go ahead and do it. I hope you found this video helpful. Please practice this as much as you can. It's a complicated subject. This video was loaded with information. I know it's a lot to absorb, but the only way you can get really good at it is to practice, practice, practice. Just Google it up, go to our website, it's stemcoder.org. Do practice problems reducing to echelon form. I hope you found this video helpful, and I look forward to seeing you in future lessons, where we're going to be doing a whole bunch of exciting stuff with row operations and reducing to echelon form.